Second part of this, multiplying and dividing radicals. Once again, I almost want to go back to a normal problem. So over here at the top, I'm going to do this. 3 times 4x plus 2. What did we learn months ago? What do you do with that 3? Yeah. So 3 times 4x is 12x, and 3 times 2 is 6. You guys are so comfortable with that that you don't even think about distributing. Now, in the same way, we're going to distribute radicals. So look at this first one. The rule says this: if it's on the inside, you multiply by the inside. If it's on the outside, you multiply by the outside. But you don't mix insides with outsides.
What?
You don't mix numbers outside a radical sign with radicands. For example, root 3 times root 5 is root 15. But root 3 times 4 is 4 root 3. You don't mix them. They've either both got to be inside or both outside to combine them. Does that make sense?
It was confusing.
Right, yeah, probably. Okay? So same thing over here. Different example. You see how the 5 is outside and the 3 is outside?
Would it be 15 square root 2?
It would be 15 square root of 2. But now in contrast to that, this next one, what's outside this root 10?
1.
A 1. So 5 times 1 is 5, and root 2 times root 10 is root 20. Now we got to pause for a second. Sometimes when you multiply radicands, you end up with a radicand that can be simplified. Think with me about 20. How does 20 break down?
4 and 5.
4 and 5. Now I need to recopy the 15 root 2 because you always want to keep your lines consistent. Now James, this is what we were working on before together. What's the square root of 4?
2.
2. So I write 15 root 2 plus 5 times 2 root 5. Just 1 2 there. Okay? So now I have 15 root 2 plus how many root 5? 10. So we really have two problems here. I'm going to draw a line between the two. Right there. Above that line, we multiplied. Why did we go further? We recognized that 20 can be done what? Simplified that. Okay, question with Zach, then with Ryan. Let's see. Are they the same radicand? Well, how does 15 break down? 5 and 3. Are they both the same radicand? So there's no pair, so we can't take it out. So since there's no pair, we have to go back to the root 15. Sometimes though, Zach, I will tell you, you will be able to break it down to this both having square root of 3 or both having square root of 5. But it has to be the same radicand. All right? Ryan? Okay, that's okay. That's why we're doing these little samples. I tried to pick samples that would explain the different ideas. Look at this next one. Root 2x, root 6x. Zoom tight. Multiply those two and you get root 12x squared. Minus 3 root 2x. Now we analyze. Look at that first radical. Does the 12 break down? It sure does.
2 and 6.
2 and 6. What about the 6?
3 and 2.
2 and 3. Minus 3 root 2x. Look at that first one. Are there any pairs? There's a pair. And there's an even exponent. What does the pair of 2's come out as? 1, 2. Now, need to help us for a second.
3.
What's the square root of x squared? Remember what the rule says you do? Cut it in what? Half. So we cut that in half, so that comes out as an x. And what about this leftover root 3?
Wait, how come you circled the x squared?
Because it's a pair of x's. I should have written XX.
Yeah. Okay.
Minus 3 root 2x. Now this is intentional. Are the answers similar? This is root 3.
It's just the opposite.
This is root 2x. Are they the same radicand? So can we combine them? No. But I did that intentionally just to make us think about it. Okay? Josh, you had your hand up.
Yeah, I was just going to say, I thought you said when you have variables,
I can't hear what you're saying.
I thought you said when you have variables and they have an even exponent, we put them with the first radical.
We could have moved that to the front, yeah. Okay. Here we go. 2 root what?
2.
9 minus what? Root 3. Good. Let's break down that 9.
3 and 3.
3 and 3. Now, James, I'm doing a little bit different here. I'm writing it as a pair instead of a perfect square. But you see this pair? That comes out as a what? Good. So I just have 2 times 3. Is that clicking now? Good.
Wait, how come it's 2 times 3?
Because what's the square root of 9?
3s.
3. I'm not done.
I forgot that the...
Okay, so 6 minus 2 root 3. Now, let me show you something that people do as an error. Sorry, question, John. Go ahead.
Yeah, there's like a minus 1,
Uh-huh.
so why wouldn't it just be root 3?
What's minus 1 times 2?
-2.
Minus 2. And then you got to tack the root 3 on at the back. Good question. No, these are all different. Here's the danger. And let me come up here to the top again for an example. What is 6 minus 4x?
6 minus 4x.
6 minus 4x. Would any of you ever make that 2x? I don't think so, would you? But guess what people want to do here? They want to write 4 root 3. Should they? No. The same way you shouldn't write 2x up here, you shouldn't combine these to make 4 root 3. To combine these, what would this have to be right there? 6 root 3? Okay, but it's not. So we're done. So we circle it. The thing about radicals is there's lots of little things, but none of that is hard. That's what I love about this. All right, our next one. Do you remember what FOIL stands for?
First.
Outer,
Less.
inner, and last. And remember the smiley face we drew? Okay, so let's draw that. As we draw the arch, let's do the multiplication. Root 5 times root 5
Is root 25.
is root 25, right? Outer, I draw underneath. Root 5 times 2 root 10. 2 root 50. I'm actually just going to leave it like so. Now the inner, the little smile, negative 2 root 10 times 5. Negative 2 root 5 and root 10. And then the other eyebrow, last. Negative 2 root 10, positive 2 root 10.
-4 root 10.
Negative 4 root 100. Okay, so let's think what simplifies here.
The middle comes capital.
We'll get to that. What about these two 5s at the front?
They go to 20. Are they going to...
They go to 5, right? What do you notice about these two middles?
They cancel?
Is that always going to happen?
No. Oh, yes. No.
Not always. Just in this case, we happen to have 2 root 15 and negative 2 root 50. So they happen to be opposite. What about this back half? I'm going to rewrite it a little bit larger. What's the square root of 100?
10.
10. 5 minus 40, help me. Negative 35. Interesting. Do you think it's always going to simplify down to one number?
No.
No. But this is a special case. Yeah.
How do you know when to break it down?
you can either leave it as perfect squares or you can break it down. There's no right or wrong answer. How do you know when to go a certain way to your next class? Is there a lot? Where's your next class? History. Could you go a number of different ways to get there? So long as you get there, so sometimes I'm trying to demonstrate, take a perfect square and take that square root, like 9 to 3. And sometimes I'm trying to demonstrate, break down the 9 to 2 pairs. It's neither is right or wrong. I'm trying to help you see there's multiple ways to do it. I'm trying not to be confusing. I hope so. I hope I'm just showing you different ways each time. That's all. All right, let's look at 6. Root 6 times 4 root 3. Help me here.
4 root 3.
4 root 18? Because what's root 6 times root 3? Root 18. Katie, in this one I'm going to multiply them all together, and then if we can break them down, we'll go from there. Okay? So that's outside. That's first. Do outside now. Root 6 times root 2.
Root 12.
Is it a plus root 12 or a minus root 12?
Plus.
Plus root 12. Inside now, little smiley face. Negative root 3 times positive 4 root 3. Negative 4 root 9. Multiply the outsides, multiply the insides. Now the other eyebrow. Negative root 3, positive root 2.
Subtract
root 6. Okay, so there's our FOIL. Now, does anything in there break down?
Yes, we did.
Okay, Katie, question?
Wait, I thought you could combine 2 terms with one.
We can only combine adding and subtracting. Now we're doing what in these steps? We're multiplying. Okay, who can break down the 18 for me? Jalon, go ahead. 9 and 2. Who can break down the 12 for me? Somebody different. Luke.
Yes. 4, 3.
4 and 3. Does the 6 need to break down? Okay, now on this second step, everything that I have in a square root, one of the numbers is what kind of number?
4.
How do 9 and 4 and 9 all relate? What are they all? They're all perfect squares. Question, Jalon?
Why are we not breaking down the 9?
I'm answering that right now. The 9 is a what?
Perfect square.
That's a perfect square. Can you take the square root of 9?
Yeah.
Okay, so that's 4 times 3 root 2. Can you take the square root of 4?
Yeah.
Okay, so that's plus 2 root 3. Can you take the square root of 9?
Yeah.
So it's 4 times 3. Can you take the square root of 6? No. So Katie, in this case, I'm not doing the pair method, I'm doing the perfect square method. It's the same thing. Let's simplify. At front I have 12 root 2, then I have 2 root 3, then I have minus 12, then I have minus root 6. Now, on a drastic comparison, number 5 simplified to negative 35. Does any of these radicals combine? Are any of them the same?
No.
So do they combine? No. So that's your answer. Is it okay to have an answer that's not simplified any smaller than it already is? Perfectly fine. I'm trying to show you the two extremes. Really simplified, doesn't combine. Both are perfectly fine. All right, flipper. What does it mean when I have a parenthesis squared?
That is times itself.
All right, so when you see a parenthesis squared, Ryan, I want you to rewrite it like this. You just need to know something squared means that times itself. Now let's FOIL. Here we go. First, 3 times 3? 9. Outside, 3 times root 6. 3 root 6. Inside, root 6 times 3. 3 root 6. Last, root 6 times root 6.
Root 36.
Root 36. All right? The 9 comes down. What do these two do?
They go together.
They go together. How many?
So 9 root 36.
What are you doing in between them?
Yeah, so
3 plus 3?
6.
6 root 6. And someone tell me, what's the square root of 36? 6. Does anything combine? The 9 and the 6, the front and the back combine to 15 plus 6 root 6. So in this one, some things combine, some things simplify. But once again, they're not always going to do that. All right, so that's an example of a binomial squared. Write it out twice, Ryan, and then FOIL. John?
So are we going to look at vectors?
No. You're just, all this is about multiplying. Adding and multiplying today. That's all we're doing, just adding and multiplying. What's that? In the future, no. You will never factor this. You'll just multiply. All right, let's look at our next one. Brett, Abby, Katie, and Tara. This one's all yours. FOIL for me. 25. 5 root 3. The fact that you didn't say negative, I'm assuming it's positive.
Then negative 5 root
Good. Negative 5 root 3. Last. Negative root 9. Okay, Tara and Abby, does anything simplify? The middles cancel. Good, they're gone. What's root 9? 3. Answer? 22. I need you to remind you of a word, guys. Conjugate. Do you remember what conjugates are? Who remembers? Only a couple of us. What are they, Zach?
Almost good. So like 3 minus 2, like 3 plus 3 plus 6.
Right.
Always cancels out.
You got it. Exactly the same binomials, except one's a plus and one's a minus, and the whole beauty of it is when you multiply them together, the middle terms cancel out. Yes, sir. Yes. On this, yeah, there's no shortcut here.
On the first one, just
No. Not that I've gone over. Upper level, yeah. Okay?
What is the shortcut?
For this,
Yeah.
well, let's look at some examples. Okay? Let me show you a couple quick. Let me show you conjugate examples. 6 minus the square root of 2, 6 plus the square root of 2. Okay, a couple other examples. What's 6 times 6?
36.
Outside, 6 root 2. Inside, negative 6 root 2. Last, minus root 4. What happens to these two?
Cancel.
So you're up to 36 minus 2, which is 34.
Is that the shortcut?
Okay? Different scenario. As you get better at them, you'll see how these work. 12 minus root 3, 12 plus root 3. What do you know about the O and the I of FOIL? For conjugates, do we even need to do them? Okay, so what's 12 times 12? 144. What's root 3 times root 3?
Negative 9.
Minus root 9. So 144 minus 3, 141. It's always going to work that way if you're multiplying what together? Yeah, conjugates. They have to be conjugates. Now the purpose of this is, notice our answer is an integer An integer, and up here on 22, it's a what? An integer. Now, what are the rules of radicals with regarding fractions? What can you not have? You can't have a radical where? In the bottom. Now I just showed you, if you multiply these two conjugates together, do you get a radical? Look down at 10 and 9. What do you have in the bottom?
Radical.
To eliminate a radical in the bottom, what could I multiply by that would get rid of the radical?
The opposite.
The conjugate. Yeah. So, here's what you're going to do, guys. Multiply this by the conjugate. Question, is that the conjugate? What should I do, Luke? You're shaking your head no.
So it's gotta be positive.
It's got to be a plus. Does it always have to be a plus? If that was a plus, this would be a minus. So the point is to eliminate the radical on the bottom, which is our goal. The way we just learned how to do that is by multiplying by the conjugate. So, watch what happens. Let's do the easy part first. What's root 8 times root 8? Which is 8. What's root 3 times root 3?
9.
Root 9,
3.
which is 3. Okay, so the bottom just becomes 5. Let's look at the top. 2 root 8 plus 2 root 3. Now I need to try to see if either of those breaks down.
Only the 2 and the 8.
Does the 2 root 8 break down? Okay, that's root 8 is 4 and 2, but the 3 doesn't. What does this 4 out front break down to?
2.
A 2. So we have 2 times root 2 plus 2 root 3 over 5. Most of what I just wrote down is exactly the same. And finally, these two 2's in the front become a what?
4.
They become a 4. 4 root 2, 2 root 3 over 5. Now my question is, do this root and that root combine?
No.
They're not the same. Now, the only thing new here is that conjugate right at the top. The simplification, that's all what? Review? Okay? All right, little mini quiz. Write down what you think the conjugate is on number 10. Don't say it, write it down. What is the conjugate you're going to multiply by on number 10? And now check, did you multiply both the top and the bottom by the same thing? All right, Abby, what was your conjugate?
11 plus
Good. All right, going from there. John or Justin, what's the top become? Good. 16 root 11 plus 16 root 7. Justin, give you the easy one. What's root 11 times root 11? Good. Minus, Hannah, what's root 7 times root 7? Root 49. So let's see. 16 root 11, 16 root 7. Someone tell me what's 121? Square root of 121? 11. What's the square root of 49?
7.
Can I stop?
No. It's gotta go down to 4.
It's got to go down to 4. Okay, rewrite the top again. Can I stop?
Yes. It can't go down.
Josh is saying no, Luke's saying yes. You must side with one of the two camps. Who says you can stop?
Who says you can?
Can. Who says that's your answer? Who says that you can't stop? Josh is hanging out there alone. All right? Then argue your position, Josh, since you're arguing with everybody.
We can't, it's not the answer because, yeah, the 4 can go into the 16 and 16.
Can the 4 go into both these two 16s?
Yes.
Okay, before you answer that question, answer this for me. If this was your answer, could you simplify?
Yeah.
You divide both the 4 and the 8 by what?
2.
2, and you'd get 2x plus 4. True? Can you divide both 16s by the 4?
Yeah.
So, yes, you can. 4 root 11 plus 4 root 7. Now, different illustration. If I had 16 root 3 plus 7 root
No.
6 over 4.
Would only be the 16.
Okay? You cannot simplify this because it doesn't go into both the 16 and the 7.
So that's your answer.
So that would be your answer. But if this was an 8,
Yes.
now could you do it? Now you could. So in order to cancel, what must the denominator go into? Both parts in the numerator. Okay, I just show you those little side examples there because those are crucial to see a couple other scenarios. All right, big idea today. Conjugates, foiling, and distributing. All right? Obviously, you had to understand adding and subtracting before we started that. So here's our assignment. Once again, I'm guessing we're going to finish this probably